All to the session of Industrial Engineering at BYJU'S Exam Prep English YouTube channel. So how many students are present? Please comment so that we'll start the session. Let me see that who are present here. So you can just comment so that I'll understand how many. Kiran, good evening Kiran. Good evening Kiran. Anyone else present here so that we can start the session very quickly. We can start the session very quickly. How are you, Kiran? Okay. Arun Kumar. Hi, sir. Arun Kumar. Hi, Arun Kumar. Okay. Raju. Yes. Fine, Raju. Yes. It is very a short particular session. Right, fine, because we are doing the transition. Yes, sir, I'm doing good. We are in transition, and basically, you all know that now we are shifting to one new channel, and entire faculties of mechanical and civil are doing the sessions at one particular platform. So there won't be any kind of a barrier of the language, right? Fine. And most importantly, you can watch the sessions there from all the faculties, irrespective of the languages, and most importantly, you can watch the sessions for Hindi and English also. So we are just filling it with a small series. We conducted already one particular session for industrial, but now we are talking about we conducted one session for production, but now this is industrial anyway. This is production written over here, but it is not actually a production, it is an industrial session. Right, fine. Let it be, it was written like that. So we'll start our discussion based on the students are available, right? Fine. So let's discuss that. Whenever we are talking about industrial engineering, I handpick some questions so that you'll get an idea about that. Very short session, and basically we'll try to understand it. Right, sir, with your permission, we'll take the first question now. In a Kendall's notation, in what? A Kendall's notation for representing a QE model, the first position represents. So what does it first represents? The probability law for the arrival, probability law for the service, number of channels, or capacity of the system. So what does it? So Kiran ka answer is straightforward. That is nothing but exactly equal to answer A. Answer is coming what? A. Straightforward. Anyone else want to comment on this particular session? Okay, what exactly is the answer according to yourself? Is there anyone who is commenting? And absolutely the answer would be exactly equal to A, because we know that the probability of the arrival is the first in the Kendall's notation, right? Fine. So we'll say that very easily. My answer is exactly equal to A. This is what exactly my answer is, right? Fine. So we'll go to the next question now straight away. Okay, fine. A, right? The Kendall's notation. Okay, fine. Answer A is completed. Consider the three activities of the CPM network as shown in the figure. There are certain activities are mentioned, right? Fine. Below. The earliest and the latest occurrence times of these events are given on the model. So whatever the model is given in that model itself, the earliest occurrence and the latest occurrence of the event is given. The total float for the activity 20 to 30. So whichever the activity is there, 20 to 30, for that we are interested to calculate. What? Total float. We are interested to calculate total float at that particular point. Can you comment on this? Okay, Raju is saying 3. Okay, fine. Someone else? We are interested to calculate the total float, right? And that is for the activity 20 to 30, not for others. So I'm not interested to the 20 to 10 to 20, 20 to 30 or 30. We are only interested in what? Only interested in a 20 to 30. So if I go and talk about, Kiran is saying A, but I have a doubt into that whether A is the answer. Let's say that we in a simplest manner, the earliest start time of activity or earliest start time of event 20 is a 10. ES. What is what? ES. So we can just highlight here, right? You can easily understand here. Earliest start time of this event 20 is a 10. So earliest by which it will start like this. And event 30, that is nothing but the activity is represented between 20 to 30. So event 30 can be completed by the latest at 23. Is it true? Yes. What is meant by total float? The total flow of any activity is nothing but what is the latest start of the end event and what is the earliest the start time of that start event. So difference between them is nothing but called as total float, right? Fine. So we can say that the total float is exactly equal to can I say that latest start time, or it can be also considered as what? A latest finish time, latest start of the activity 30, right? Latest start of the activity 30 minus earliest start time, that is what? Event 30, that is for event 20, and minus activity duration. And what is activity duration? Activity duration given here is exactly equal to 8. Activity duration given here is 8. So what is answer is coming? Now we'll say that, sir, latest start time is 23 minus 10. So I'll say that 23 minus 10, right? Fine, minus 8, right? Fine. So answer is coming what? 23 minus 10 is 13. 13 minus 8 is exactly equal to 5. 8 is exactly equal to what? 5. So this is exactly equal to answer. Answer is coming D. That is what exactly correct answer is. Answer is coming what? D is my perfect answer. Do you understand that? Yes, answer D would be a perfect answer for me. Right? Fine. So this kind of questions also comes in examination. You should be so sure about that. Right? So answer is exactly equal to D. Next question. Now in this particular theoretical data is given, and in that theoretical data some particular questions are developed. What is that? The earliest occurrence time for the event 1 is 8 weeks and the latest occurrence time for the event 1 is 26 weeks. Right? The earliest occurrence time for the event 2 is 32 weeks and the latest occurrence time for the event 2 is 37 weeks. If the activity time is 11 weeks, then the total float will be, again the total float, instead of giving the diagram, instead of giving that network diagram, it is given a theoretical data, and based on that we are interested to calculate how much is the total float. Can you able to calculate how much is the total float in this case? Can we able to calculate how much is the total float in this particular? So if you don't understand, you can go and draw that network diagram also between the activity or event 1 and the 2. Event 1 and the 2. So I can say that this could be my event number 1 and this could be exactly equal to event number 2. So between event 1 and event 2, we can just draw the network diagram. This will be event 1, this will be event 2, and let's say that activity is A. We can say anything A, B, C, D. I'm saying that activity is A. Activity is exactly equal to A at that particular point. Is it okay? Yes. So what it is given, earliest occurrence time of event 1 is 8. So I will say that earliest occurrence time, earliest start time of event 1 is exactly equal to 8 week, right? Fine. And the latest occurrence time of event 1 is 26 weeks. Latest occurrence time of event 1 is exactly equal to what? 26 weeks. So I'll say that latest occurrence time, right? Latest start time is exactly 26 weeks. Now as far as event 2 is concerned, earliest occurrence time for the event 2 is 32. I'll say that 32, and it was given that the latest occurrence time for the event 2 is 37. That is for latest start time is exactly 37. And the activity duration, activity time is exactly equal to 11 weeks is exactly equal to activity duration. So how much exactly total float for this particular activity? So I know that, sir, total float is exactly equal to latest occurrence of the event number 2. How much it is? 37 minus earliest occurrence is 8. So this is exactly a total gap is present between which the activity can be completed. And for completion of that activity, how much time is required? Activity duration is exactly equal to 11. Activity duration is exactly equal to what? 11. 37 minus 8 minus 11. 37 minus 8 is 29. 29 minus 11 is exactly equal to 18. 18 weeks will be answer. Is it okay, everybody? Kiran Kumar is absolutely correct. The 18 would be a perfect answer for this particular point. Right? Fine. 18 would be a perfect answer for this particular case. So let's see that what is exactly answer. So answer is exactly equal to 18. Right? Fine. So this would be my answer. No doubt into that. Answer is exactly equal to this much. Now let's say that very simplest question are selected. Right? Fine. Because only one session is there because of that. Right? Fine. So now let's question is that a local tire distributor expects to sell approximately 96,000 steel belted radial tires next year. So that in the next year we can say that demand is exactly equal to not 96,000, it is 9,600. Annual carrying cost is 16 per tire and the ordering cost is exactly equal to 75. Ordering cost is exactly equal to what? 75. The economic order quantity of this tire is Is it 300 economic order quantity? I don't know. Right, fine. Let's check it that. Sir, the demand, annual demand is exactly equal to given 9,600 units, right, per year. This is exactly equal to annual demand is given per year. This is exactly equal to annual demand is given. Right, fine. The annual carrying cost is 16 per tire. Annual carrying cost is 16 per tire. So can I say that, sir, carrying cost CC is exactly equal to rupees 16 per tire, right? Fine. So whatever the data is given, I'm just filling the data, right? Whatever data is given, I'm just filling the data. Now let's say that ordering cost, how much is the ordering cost? So I'll say that ordering cost is given rupees 75. So I'll say that CO order cost is exactly equal to rupees 75 per order. Per what? Order. And we are interested to calculate a economic order quantity, EOQ, we are interested to calculate. So how much is the economic order quantity? So can I say that economic order quantity is exactly equal to 2 into D into CO divided by CC. This is the standard. I would say that the formula is there. Maximum questions would be asked only on this particular platform with the minute changes. 2 into D into CO divided by CC. So what is the value of D? Annual demand is exactly 9,600. The order cost is exactly equal to rupees 75. And the carrying cost is exactly equal to rupees 16. Carrying cost is exactly equal to rupees what? 16. Is it okay, everyone? Yes, carrying cost is exactly equal to rupees 16. Right, fine. So if I do the analysis, what is the answer is coming? Let's check it that. The answer would be coming exactly equal to a 300. 300. What will be answer? So answer is coming economic order quantity is exactly equal to 300 units. This is not a rupees. This is what exactly unit is. This is what exactly unit is. Is it okay, everyone? Economic order quantity is exactly equal to 300 units. I hope so you are understanding this, right? Fine. We are talking about next question. Again, the simplified data is given, and from that simplified data, we are interested to ask the question, right? Fine. An atom can be purchased for rupees 100. So the cost of unit cost of the item is 100. The ordering cost is rupees 200. The inventory carrying cost is 10% of the atom cost per annum. Right, fine. If the annual demand is 4,000 units, then the economic order quantity is, then how much will be exactly equal to economic order quantity at that particular point? Now, how much exactly equal to economic order quantity? Is it coming D? So the data is given that the item cost, that is unit cost, is given rupees 100. Unit cost is given what? Rupees 100 is a unit cost. The ordering cost, so can I say that order cost CO is exactly equal to, order cost is exactly equal to rupees 200 per order. Rupees what? 200 per order. This is what exactly order cost is given. Order cost is given what? Rupees 200. Right, fine. If the annual demand is 4,000, so annual demand is given, that is exactly equal to rupees 4,000. Not rupees 4,000, it is nothing but a items, right? 4,000 items are there, we need to sell in the market. Now the economic order quantity we are interested to calculate, and the carrying cost is given is 10% of atom cost per annum. So can I say that carrying cost is exactly equal to, what is the carrying cost? Carrying cost is exactly equal to rupees 10% of the item cost. So 10 by 100 multiply by 100, right? Fine. So that is exactly equal to rupees 10, right? Fine. Per annum. So per annum, right? Per year. Okay, fine. So all the data is given to you. If the data is given to you, so can I say that it is given that economic order quantity is exactly equal to root of 2 into D into CO divided by CC, right? 2 into D into CO divided by CC. This is exactly equal to economic order quantity. Economic order quantity would be like that. So I'll say that economic order quantity is exactly to demand. So can I say that how much exactly is the demand? So you check it that what is the demand. So demand is 4,000 units. The unit cost is not required. Ordering cost is 200, right? Fine. So I'll write down 2 into demand is 4,000 multiply by order cost is 200 and carrying cost is exactly equal to 10. How much is carrying cost? So carrying cost is exactly equal to 10, and this has to be in the root. This has to be in what? Root. This has to be in a root. Right, fine. So I'll say that, sir, economic order quantity comes exactly equal to how much it is coming? So it is coming 400 units. 400 units is economic order quantity is coming. Is it 400 unit is answer? Yes, Kiran Kumar. Yes, absolutely correct. 400 is the answer. I think so. Yes, this is what exactly my answer is coming. Is it okay, everyone? 400 is my answer. Perfect answer would be what? 400. Okay, we'll go to the next question now. Which one of the following is the correct statement in a standard form of the linear programming problem? So whenever we talk about linear programming problem, there is a function that is called as a optimum function, maximization, minimization, and then there will be certain constraints are given. So can I say that in the linear programming problem, when the LPP we stand for, so what exactly are the constraints are there? The constraints are of less than or equal to type, or constraints are of greater than or equal to type, or in the form of equations, constraints are always in the equations, or some constraints are less than equal to type and the some constraints are greater than equal to type. So what will be your take? So we are not talking about the any kind of problem. I'm talking about LPP. So we know that whenever we are talking about the standard form of LPP, can I say that whichever the constant equations are there, these equations has to be converted into a standard form. And standard form is nothing but what? Either it has to be, if there is less than, then can I say that variable has to be added. Artificial variable has to come in the picture, right? Fine. So therefore, can I say that it has to be in the form of equations? It has to be in the form of equations. So we'll say that, sir, it has to be in the form of equations, right? It has to be in the form of equations. There is no single doubt into that. It has to be in the form of equations. Is it okay, everyone? It has to be in the form of equations. No doubt into C. Some constraints are less than or equal to and some constraints are greater than or equal to. It cannot be called a standard LPP problem. For standard LPP problem, it has to be bound to happen that some constraints should not be like that. All the constraints should be what? In the form of equations. Right, fine. Now, the data for the break-even. What is that? The data for break-even analysis of a product are given as fixed cost is rupees 10,000. The variable cost is rupees 10 per unit. And selling price is rupees 15 per unit, right? Fine. The break-even volume is, so how much exactly going to break-even volume? How much exactly a break-even volume? So it was given that the fixed cost is exactly equal to 10,000, right? Rupees 10,000 is the fixed cost, right? Fine. Then I'll say that, sir, selling cost, variable cost VC is exactly equal to rupees 10 per atom, that is exactly per unit atom, right? Fine. Then I'll say that sales price is exactly equal to rupees 15 per unit atom, 15 per unit atom. So how much exactly equal to break-even quantity, right? Fine. Now if I want to calculate break-even quantity, we know that, sir, break-even quantity BEQ, break-even quantity is exactly equal to, can I say fixed cost divided by what? It's very simple, sir. Fixed cost is exactly equal to selling cost minus variable cost. So the fixed cost is exactly equal to, I'll say that 10,000 rupees is the fixed cost, right? Fine. Divided by, can I say that what is the selling price? 15 minus variable cost 10. So answer will be coming exactly at 2000 units is exactly equal to break-even quantity. Break-even quantity is exactly equal to 2000 rupees. All these questions, right, are getting by-hearted to the Kiran, right? Answer is this, right? Fine. Now if I want to lower the break-even point, the break-even point can be lowered by, so what is the option? We are interested to lower the break-even point, and we have discussed that whenever we are interested to lower the break-even point, so I'll say that, sir, break-even quantity, just now we have discussed that. What is the break-even quantity? We know that whenever we are saying the break-even quantity, can I say break-even quantity is exactly equal to fixed cost divided by sales price minus variable cost. So I'll say that sales price minus a variable cost. Sales price minus what? Variable cost. Break-even quantity is exactly equal to sales price minus variable cost. So now it's very simple that the fixed cost, I'm interested to lower the break-even quantity. So that means left hand side has to be lowered. So can I say that by mathematical way, can I say fixed cost has to be lower? Fixed cost has to be lower, no doubt into that, right? And the denominator has to be increased. And to increase the denominator cost, can I say that, sir, that sales price, that is not exactly equal to sales price, cannot be represented like that. Sales price has to be represented by the simple way, that is nothing but I'll say that, sir, sales cost, right? Fine. So can I say that if it has to be increased, sale price has to be increased and variable cost has to be reduced. So these are the options are available. Any of them you can select, right? Fine. So I'll say that increasing the fixed cost, no sir, fixed cost has to be reduced. Fixed cost has to be reduced because we have to lower the break-even point. So increasing the variable cost, No, sir. It is also decreasing the slope of the income line. No. Reducing the variable cost. Yes. So what will be answer? Only one option is there, that is delta D, reducing the variable cost. Reducing the variable cost. So I'll say that, sir, this has to be my answer. And don't buy heart these particular things. Don't buy heart these particular things. Right? Fine. So this is exactly good option is. Right? Fine. Now again, one more simple question is there. Using the exponential smoothing constant or using exponential smoothing, a car manufacturing company predicted the demand for the year as 1040 cars. The actual sale was found to be 1140 cars. If the company's forecast for the next year is 1080, what is the value of the smoothing constant? What is the value of smoothing constant? And smoothing constant is nothing but alpha value we are interested to calculate. Alpha value we are interested to calculate. So how much exactly equal to smoothing constant at this particular point that we have to calculate? Can you able to calculate smoothing constant? 0.4. I don't know. Let's see that. Sir, smoothing constant, that is nothing but called as a forecasting. Forecasting for n plus 1 month is exactly equal to forecasting for n month plus alpha into forecasting minus demand minus forecasting. Right? It is exactly about that. So I'll say that demand for n month minus forecasting for n month. Right? Fine. So forecasting for n plus 1 month is exactly equal to forecasting for n month. It was given that company predicted demand for the year as 1040. The actual sale was found to be 1140. Right? So I'll say that, sir, this is alpha. Demand is exactly equal to, for nth, what is the demand? Actual demand is exactly to 1040 minus the predicted demand for the year is this. The actual sale was found to be 1140. So actually this is what exactly 1140 and the forecasted value is exactly equal to 1040. Right? Fine. So this is 1040. It was given that the company's forecast for the next year is exactly to what one? 1080. Right? How much alpha is coming? I don't know. You calculate and tell me how much answer is coming. Kiran, you saying first of all 0.4 and then you are saying 0.6. This should not be accepted. You tell me that. How it is? Is it correct 0.6 only? You tell me that I don't know. I don't know the answer. You tell me that it is 0.6 or 0.4. So I think so 0.6 would be a correct one. Right? You can do the calculation and you can say that this would be my answer. This would be exactly equal to my answer without a doubt. Yes, 0.6 is correct. Yes. Okay, fine. Now consider the following linear programming problem, right? Maximization function, that is optimization function, is 2a plus 3b. Subjected to, there are certain constants are given. What can say about this solution? So what we can say about this solution? It may have contain alternative optima, or it may have a solution will be unbounded solution, or the solution will be a degenerate solution, or it cannot be solved by the simplex method. What will be your answer? So based on whatever the maximization function and what exactly equal to that objective functions is given, based on that it may contain alternative optima. And why is it so alternative optima? Because we know that if you see that optimization function, that is z max, this is what exactly objective function is, that is exactly 2a plus 3b, and here variables is exactly a and the b are a variable. Generally we used to take a variable x and the y, but here the variable is exactly a and b are the variable. Nothing to worry about it. Why to worry about it, right? And objective function is subjected to a plus b, this one. But I'll say that the objective function, sorry, the constants value are exactly 4a plus 6b, 4a plus 6b less than equal to 30. Less than equal to what? 30. 4a plus 6b is less than equal to 30. So can I say that here, if we say that a slope, if I calculate slope here, that is xy by intercept, sorry, y by x intercept. So y intercept is 3 divided by x intercept is 2. And here also the slope of this line is exactly equal to, can I say that is exactly equal to 6 by 4, that is exactly equal to 3 by 2. So can I say that when the slope of the any constant line is exactly equal to slope of the objective function, then can I say that it will be having a what? The multiple optima. It will be having a multiple optima. You don't require, if you go and solve this by the simple graphical method, you will say that this is what exactly line is coming, and on this line any point will give you same maximization value, any point. So this will be having what? A multiple optimal solution. It is called as what? Multiple. It is called as what? A multiple optimal solution. Multiple optimal solution. Multiple optimal solution. Is it okay, everybody? Yes, multiple optimal solution. I hope so you're understanding that this is what exactly multiple optimal solution is coming in the picture. Why? Because I told you that in a simple grammar, what it is basically, I would simply say that, sir, whenever the slope of any constant is exactly matching to the slope of the objective function line, then that particular will be having, that LPP or the problem will be having multiple optimal solution, a standard value, right? Fine. Now, which one of the following is the correct statement? In the standard form of linear programming problem, all the constants are, can I say that all the constants are of the equation equality type? Already we have discussed, I think so, it is equality type, right? Fine. So this is the short session we had for the filling up time, right? Fine. Slope of constant equal to objective function, right? Fine. And this is what exactly story is. So now we'll meet into the new channel with the new sessions, right? Fine. So thank you for joining everybody. Please do remember that now whichever the channel was there as the BYJU'S Exam Prep Hindi YouTube channel, that will be now a channel for mechanical and civil. And in that channel, entire faculties of the mechanical civil will come in together, and there will be a sessions for English and the Hindi language also. So no more, I would say that any kind of unwanted notifications. It will be relevant to only a mechanical and civil students, and all the faculties will be sharing same dais. So you'll also enjoy it. So this is what exactly a filling up series. I hope so. You must have enjoyed some particular, I would say that questions. I request all the students share amongst that, download the BYJU'S Exam Prep app, subscribe that channel, and be ready to upcoming sessions which are going to come. Kiran Kumar, you are all active, right? Thank you for joining. All the rest of the students who are going to watch this session in the video, I'll say that please do join the new channel so that we'll be also interacting so much, right? Fine. So thank you all. God bless. Take care, and we'll meet you in the next session. All the best.